Quadratic formula. If we want to solve a polynomial equation that's degree 2, we have one final option, which is the quadratic formula. And so, for instance, if we want to solve x squared minus 7x plus 10 equals 0, because it's degree 2, we have the option of using the quadratic formula. In this case, this one factors, and it's not hard to solve this one through factoring, but we will run into some polynomials that don't factor, and so we'll want to be able to use the quadratic formula for this. And the way the quadratic formula works is if we have an equation of the form ax squared plus bx plus c equals 0, then the solution is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And we can just immediately take our numbers, plug them into this formula, and it will give us the solution. So in this case, we have a equals 1, b equals negative 7, and c equals 10. It's important to realize when you're doing this, though, that all of the terms have to be on the same side of the equation, and it has to be equal to 0. Okay, so now plugging in these values, we get that x equals negative b, or the opposite of b. So the opposite of negative 7 is positive 7, plus or minus square root of negative 7 squared minus 4 times 1 times 10 divided by 2 times 1. Okay, so this is going to be 7 plus or minus square root of 49 minus 4 times 1 times 10 is 40 all over 2. So 7 plus or minus square root of 9 over 2. So 7 plus or minus 3 over 2. And now at this point, we probably want to split this up into two separate solutions. We get x equals 7 plus 3 over 2, which is 10 over 2, 5. And x equals 7 minus 3 over 2, which is 4 over 2, which is 2. So our two solutions are x equals 2 and 5. Now, in this case, we could have gotten this from factoring, but this will allow us to solve polynomial equations of degree 2, even if it doesn't factor. Okay, another example, if we want to solve 3x squared minus 8x equals 12. First thing we need to do is make sure that all of our terms are on the same side of the equation. So we move the 12 to the other side, and we end up with 3x squared minus 8x minus 12 equals 0. And now we can apply the formula. So x equals the opposite of b, so the opposite of negative 8 is positive 8, square root of negative 8 squared minus 4 times 3 times negative 12, all over 2 times a, so on the bottom we have 2 times 3. So this is going to be 8 plus or minus square root of 64. 4 times 3 times 12 is 144. And a minus and minus cancel, so we end up with 64 plus 144 over 6, which is 8 plus or minus square root of 208 over 6. We could leave it like that, but usually we want to simplify our radicals as much as we possibly can, so we're going to be looking for the largest perfect square that goes into 208, and in this case it's 16. So 208 is 16 times 13. And so we end up with 8 plus or minus 4 square root of 13 over 6. Now also we notice that 2 goes into all three terms that we have here, so we can factor out a 2 and then simplify this further. So we can get 4 plus or minus 2 square root of 13 over 6. Now we could have factored out a 4, but since 4 doesn't go into 6, there wasn't any need to do that. We can cancel the 2 and the 6, leaving us a 3 on the bottom, and we end up with x equals 4 plus or minus 2 square root of 13 over 3. And that's our solution set. We can leave it like that with a plus or minus, or we could write it as 4 plus 2 square root of 13 over 3, 4 minus 2 square root of 13 over 3. Either solution is acceptable there. Okay, so let's look at one more example. Say we have 2x squared plus 5x plus 7 equals 0. Okay, so we plug this into the formula, and we get x equals negative 5 plus or minus square root of 5 squared minus 4 times 2 times 7 all over 2 times 2. Simplifying this, we get negative 5 plus or minus square root of 25 minus 56 over 4. And 25 minus 56 is negative 31 over 4. Because we got a negative inside the square root, that means this is not going to have any real solutions. We can write this as complex solutions, and we would have x equals negative 5 plus or minus. Now the square root of a negative just means we're going to get an I, square root of 31 all over 4. And this can't be simplified any further. So whatever happens inside the square root is going to determine how many solutions you have. If you get a positive number inside the square root, you're going to end up with 2 real solutions. If you get a negative number inside the square root, you're going to end up with 2 imaginary solutions. If you get a 0 inside the square root, then you're going to get 1 single real solution.